Hey everyone. All right, we're going to take a look here at section 3.4 linear programming. I'm going to take some time. I'm going to run through a whole problem with you, specifically this last example from your notes. I actually really like this example. Woo! And I wanted to make sure to run it through with you on this video, just in case you were having some trouble and we needed to kind of clear some things up. So let's get going. All right, we're baking a tray of corn muffins. And we're also baking a tray of bran muffins. So we got corn muffins takes 4 cups of milk and 3 cups of wheat. Tray of bran muffins takes 2 cups of milk and 3 cups of wheat flour. A baker has 16 cups of, that should be milk with a K, and 15 cups of wheat flour. Hashtag get it together, fish. He made $3 profit per tray on corn muffins and $2 profit per tray of bran muffins. How many trays of each type, of muffin should the baker make to maximize his profit? So, what are you trying to find? Remember, the first step, we want to figure out what are we maximizing or minimizing. Well, in this case, we're going to maximize the profit. We're going to make it rain. Dollar, dollar bill, y'all. So, in the problem, you want to look and think, well, where is it discussing a maximization of profit? Right here and right here. So, our objective function is going to come from what I've underlined in blue, which is going to be our profit function, which is, well, let's figure that out. What are we comparing? It looks like trays of corn muffins, ooh, and trays of bran muffins. So I'm going to let, and I actually, before I even write P equals, right? You should have yelled at me about that. I'm going to make sure that I let X equal the number of trays of corn muffins. Corn muffins. And then we're going to let Y equal the number of trays of bran muffins. You won't like those until you're older. Sadly, I like bran muffins now. Hashtag don't judge me, please. Okay, so we got bran muffins. So then our profit is going to be coming in the form of $3 per tray of corn muffins, so 3x, but we're making an additional profit of $2 per bran muffin tray, okay? So 3x plus 2y is going to be our objective function. Once we have talked about that, guess what? It's gone. All that information is gone. So I'm literally going to enlarge the pen, and I'm just going to cross all that out. Goodbye, 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 you're gone. You are the weakest link, goodbye. Because then from the rest of this situation is going to come my constraints. So the first thing that I noticed is that we were talking about milk, cups of milk, and cups of wheat. So I'm going to focus on the milk. So the cups of milk for the corn muffins, and then for bran muffins, we have cups of milk being 2, and then we have 16 total cups, okay, of milk. So for each tray of corn muffins, we use 4 cups of milk for each tray of corn muffins. In addition to that, we also, for bran muffins, use 2 cups of milk. But we have 16 total cups of milk. Does the baker have to use every single cup of milk? The answer is no, but they can't use any more. So they could use less than or equal to. Less than or equal to, and in that case it'd be 16. Excuse me. The next part is, well, I have my wheat. So I'm going to look at my corn muffins with the wheat flour, my bran muffins with the wheat flour, and then the baker having 15 cups of wheat flour. Similar setup. You're going to have 3 cups per number of trays of corn, but also you'll have 3 cups per number of trays of bran, and you have the baker has 15 cups of wheat flour. Can't use any more, can't use 16, 17, 18 cups. He's not going to the store, hashtag lazy, but rather he can use up to the 15. He could use all 15 if he wanted to as well, okay? Guess what? If I look there, if I really cross everything out that I've used, I got that gone, I got this information gone, I got this information gone, I got this information gone, this. Look at me, it's just like a coloring board. It's crazy. Is there any other information in the problem? The answer is no. But remember, we're dealing with a real life situation. Can you make negative trays of corn muffins? No. So these are your hidden constraints. You can't make negative trays of corn muffins, but you could decide not to bake any. So that's why it's equal to. Similarly, you can't bake negative bran trays of muffins, but you could bake 0 of them. There, my friends, is going to be your system of inequalities, i.e. your constraints. So now we have to get those constraints graphed, go to town, do our thing to maximize the profit. All right, to get that graph, I'm just going to use the intercepts. Totally on pitch today. So if I have for my y-intercept and then for my x-intercept, can I cover that up with my finger? I don't think I have that kind of skill. But if I were to hide it, let's see, I'll try and hide it. You can't see me. If I hide the x, i.e. I cover up the x, I have 2y equals 16. So that's going to just be 8 for your y-intercept. If you cover up the y, you have 4x equals 16. So you're going to get 4 for the x-intercept. Similarly, down here, you are going to be getting what and what? Well, you're going to be getting pretty much the same for each of them because they're both 3 as coefficients. So when you cover up your x, you're going to get 3y equal 15. Divide both sides by 3, you get 5. Similarly, when you cover up the y, when y is equal to 0, you cover this up. You would then have 3x equal 15. You get 5 when you divide. So I'm going to get those plotted, but I'm going to label my axes. So this is going to be number of, actually, let me color code it. I'm feeling a little frisky with color right now. No, frisky is a terrible word. Please forget that I ever said that. But rather, I'm feeling a little obligated to work with the appropriate colors. So I'm just going to work with my corn muffins, the number of trays, and then I will work in orange with my lovely dovely bran muffins. Oh gosh, how can I do this? So the number of bran, that is impressive, people. You have no idea number of trays. You have no idea how impressive that is. Do I have to change my scale at all, or can I go by zeros? By zeros. By ones, I mean. I think I'm okay with going by ones and keeping this on here. Remember, you do want to be conscious of that. Get these intercepts first before you actually graph it. It's a good idea. So here, I'm bounded by my axes, here and here for my hidden constraints, and then I'm going to get these graphs. So I got 0, 8, 1, 2, 3, 4, 5, 6, 7, 8. Don't you love that I have to count like that? And then I have 4, 8, or excuse me, 4, 0. You get your straight edge on. Do I have a straight edge over here, people? Seriously. Let me see if I can make this happen. Oh my gosh, I'm setting a straight edge on the slate. This is so cool. Ah! Undo that. I didn't mean to do. Okay, I'm not even going to try it. Never mind. So with your straight edge, do as I say, not as I do. Boom. Connect the dots. Nice. Remember, rock solid because it is equal to included. Am I shading above or below that? I'm going to be going below. Baby, as the sky is falling down. And then for my other, I got 5 and 5. So I'm at 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Connect those dots. La, 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 la. And I'm shading below that as well. So notice where we're going to be shading then is this region that may look triangular, but it's not triangular at all. Rather, it is quadrilateral in nature because we have 4 vertices. A little tricky to see, so I colored that in beautifully. Oh, so proud of myself. And then we're just going to go here and color here. So here is 1, 2, 3, and then this 4th one. 1, 2, 3, and then our 4th one. All right, so 1, 2, and 3 are all pretty straightforward. You're going to end up having, for number 1, your vertex at 0, 5. For number 2, it's at 0, 0. For number 3, it's at 4, 0. But then for number 4, things get interesting, right? Maybe yours turned out perfectly. Mine certainly didn't. But whenever it's close, you want to check it in a system. So let me show you that system setup. Notice the ones that hit were my 2 colored, my purple lavender and my orange. So I'm going to go back up here, and I'm going to take those 2, and I'm going to make a system of equations because you're trying to figure out that vertex point, that singular point where they're equal, and I'll just solve them. Here, actually, what I'll do, oh, look at me, my bad self. I'm not going to use elimination. I think I'm going to actually use substitution. Nah, let's use elimination. Let's go crazy. So let me just solve this briefly. I'm going to multiply the first by a 3. Let's just eliminate the x and the second by a -4. Okay. So all this work, we're loving it. Putting so many targets together. Distribute the 3 plus 6y equals 48. Then distribute the -4, that's -12x, minus 12x equal -60. Over here, cross that out. -6x equals -12. Oh, so x should equal +2. So you should have had a nice number. Or maybe not. Oh, that's y. Oh, I can't even read my own writing. That's embarrassing. Hashtag, are you embarrassed for me? I know Katie is. Oh, I'm so sorry, girl. And Dante, I'm embarrassed for myself, too. Just please don't argue, okay? No arguing, right? Keep Nate out of this. Pauline, it's okay. Love you, girl. So y equals 2. So then you can substitute back in. If y equals 2, you'd have 3x plus 3 times 2 equal 15. That's 6, so I'm going to subtract 6. I get 3x equals 9. So x equals 3. So if you drew yours a little better, you probably had a nice ordered pair. But I'm just letting you know, my friends, this is how you would algebraically accomplish this task. It's important that you're able to do that because as you saw in the one example in the notes yesterday, and probably as you'll see on maybe 1 or 2 examples, not necessarily in these notes, but in the practice, you're going to have to do that, okay? Are we done? Heck no! We're close though. We just have to plug these into our objective function and figure out the maximum value because we're trying to maximize the profit. So you're going to have 3 times 0 plus 2 times 5. That's going to be a value of 10. 0, 0, clearly just going to be 0 plus 0, which is 0. Not happening there. You better sell something to make some profit. 3 times 4 plus 2 times 0 is 12. Looking better. That looks better. But then if we take 3 times 3 from our fourth point plus 2 times 2, that's going to be 13. So notice which is the max value right here. What is the max value representing? The profit. That's what I have underlined in blue up here. Is that what the question is? No. The question asks you, how many trays of each type should the baker bake? If the baker wouldn't bake and the baker would bake and the baker bake, I don't know what I just like bakers. They're cool. They should bake 3 trays of corn muffins. And then how many trays of bran? 2. 2 trays. 2 trays of bran. Excuse me. And that's your solution. So I'm going to put big stars around this. Because technically what's in black there, that is your answer. Okay? Please don't hesitate to reference this problem. I think it's a really good one, and I think that it should help you if you watch it, if you're having some trouble. Because, hey, if I can't be there, at least I can be there remotely. Kind of, sort of, but not really, because that'd be kind of creepy. All right, hashtag have a good day. Peace out, homies. Hope you enjoyed. Bye now.